As far as human history is concerned, until a short time ago, it was thought that our Earth was at the center of the universe. This was the general opinion. Everyone took this information as certain knowledge, and those who opposed it were perceived as irreligious rebels and were punished and even ended up dead. You see, people had a very difficult time today because of a knowledge that we all learned as children and laughed when told otherwise. But one of them was going to take a step to start a revolution. Nicholas Copernicus, or Copernic as most of us know it. Copernicus started this revolution. Even if there was a misconception that the sun was the center of the universe, he changed the whole misperception with a revolutionary idea for that time and developed a very revolutionary point of view among those who believed that the Earth was flat and at the center of the universe in the 15th century. Even in 2025, there are still people who say the world is flat. Those heads could have lived very happily in the 15th century. Anyway, let's get back to the subject. Of course, these thoughts will not change immediately, and Copernicus would have the good fortune to die within a year of publishing his work and escape the wrath of the conservative community. Of course, they would continue to reject all of Copernicus's ideas for several centuries. Then in the 17th and 18th centuries, with the contributions of scientists like Newton, this perception will be fully established, and that we live on a planet orbiting an average star in the universe. At the beginning of the 20th century, we would learn that there were other galaxies, and with the isotropic, or directionally independent model of the universe, we would understand that the universe had no center, and we would end our search and turn our attention to very different findings. In 1998, in a study called Type 1a supernova, beyond the knowledge that the universe is expanding, it was also found that the expansion of the universe is accelerating. So we knew that the universe was expanding. With the vacuum theory, the theory that space is empty, one would think that this expansion should be constant. But something was accelerating this expansion. Something we can't see or whatever. But to answer that, we need to ask a few questions first. How did matter come into being? Where do we come from? So it's not just us. Everything on our planet, planets, stars, galaxies. So it's not just us. Everything on our planet, planets, stars, galaxies. When we look at this iconic photograph taken by the 1111 Hubble telescope, we see tens of thousands of galaxies. Some of them are very faint, because it's very old, because this light is coming from about 13 billion years ago. So when we look at this light with this telescope, we are traveling back in time, to the starting point, to the Big Bang. But the question is, where did the matter that makes up everything? Where did the matter that makes up everything come from? Stardust. Where did it come from? Well, we seem to have an answer to this cosmic mystery. We think that everything we see is the result of a great battle between two things we can't see: dark matter and dark energy, which we have only recently discovered. Dark matter and dark energy together rule the universe. But to do that, we first had to look much further back than the Hubble telescope. Much further back than the Hubble telescope. We had to time travel back to the beginning. To this end, in 2001, we sent a satellite called WMAP into space, and its purpose was to capture the first light of the universe. The first light of the universe? Yes, the first light of the universe. We're talking about the light that was created about 380,000 years after the Big Bang, when light became too dense to be emitted, a phenomenon that led to the emergence of the Big Bang theory, cosmic microwave background radiation. It was discovered by pure chance in the 1960s due to interference in radio signals. This radiation was detected by two astronomers, Arno Penzias and Robert Wilson. Here's a legacy left behind by the Big Bang. In 1992, the COBE satellite sent by NASA proved the existence of this radiation for the first time, and the WMAP satellite set out to make a detailed map of this radiation. And after 9 years of work, this photograph would emerge. This is what's called a baby picture of the universe. This is the signature of the birth of the universe, the signature of the Big Bang. By looking at these different color patterns, astronomers can clearly see what happened since the birth of the universe and calculate the age of the universe much more precisely, 13.7 billion years. But the most important piece of information was this. More than 95% of the universe was filled with what we call dark matter and dark energy, a force and matter that boggle the mind. Now let's talk about how we came to this conclusion. And for that, we need to talk about speed. As you know, the Earth revolves around the Sun at a speed of 1,670 kilometers per hour. Do you know how fast our solar system orbits around the center of the Milky Way galaxy? About 800,000 kilometers per hour. That is an amazing speed. But there is something strange here. If you look at our solar system, as the planets move away from the Sun, their rotation speed decreases. It rotates more slowly. This is what Newton's laws tell us. The speed should decrease as you move away from the center. By this logic, we can conclude that stars rotating relative to the galactic center should also decrease in rotation speed as they approach the edges of the galaxy. But here is the strangeness. No matter where the stars are in the center of the galaxy, as they get farther away, they are expected to rotate more slowly, but almost all of them rotate at the same speed, and some stars even rotate faster. What do you mean? It was very strange. And the story of Vera Rubin, who made this discovery, is just as extraordinary. In the 1960s to 70s, in a male-dominated environment in astronomy as everywhere else, Vera Rubin, who has been curious and fascinated by space since her childhood, chose it as her profession. While everyone else was focused on the center of galaxies, he focused on the stars outside galaxies. And that's when he made this crazy discovery. It was truly extraordinary, and there had to be an explanation. Vera Rubin, the unsung heroine whose name few people know, was going to explain this too. She was going to do this even though she was denied admission to the astronomy program at Princeton University because she was a woman, and even though she had 4 children. For her, there could be only one explanation for this situation. For example, here you see the Andromeda Galaxy. It's one of the closest spiral galaxies to us. Here, the stars outside the beam of light were moving as if they were very close to the center. The only explanation is that even if there was no light, there must have been something. There must be matter. It had to be dark matter. Vera Rubin's observations showed that galaxies were embedded in a ring of what we call dark matter, a substance that our telescopes could not capture. That galaxies don't move in a vacuum, but in this matter. That this matter makes up most of the mass of galaxies. When we look at the sky, we are actually looking at a tiny part of a galaxy. We see dust grains in an ocean filled with invisible matter. We are in an ocean, but here's the problem, the biggest problem. Dark matter is not like any matter we know. Nothing we know, nothing we see, no planet, star, galaxy. There is no trace of this substance in anything. It doesn't look like anything we know. And that's why we're in a really big darkness when we're looking for dark matter. We are sure that it exists. One of the main indicators of this is the formation of stars. How did stars form in the first place when there were no conditions for them to form in the first place? How did atoms decide to come together and form stars? Here is the answer to that. When we look at the WMAP map, we can see that dark matter is dense in some places. This density caused the dark matter to produce a gravitational effect, and atoms fuse together at these points to form stars. They are out there, but we don't know where they are. Are we trying to find them? Yes, where are they? And that's exactly where it is. At CERN, at the Large Hadron Collider. What are we doing at CERN? Here's how it works. In a previous video, we briefly talked about the Standard Model and the 4 fundamental forces in the universe. We will talk more about it, but here's what we mean by the Standard Model. Subatomic particles, the particles that we think make up atoms and therefore everything we see in the universe. These are fermions, the particles that make up all the matter we see, and bosons. And bosons are the particles that enable the exchange of forces between fermions. The 3 fundamental forces, the strong, weak nuclear, and electromagnetic forces, are carried by these bosons. If you ask where gravity is, the Standard Model has not yet been able to include this force in the equation, but this will happen at some point. Question: here are the fermions or bosons that make up the protons and neutrons in the nucleus of the atom. The most elementary particle is called quarks, and this is the smallest particle we know of that has mass. But the question is, where does this mass come from? And Peter Higgs provides the answer. These particles are called the Higgs field, which is thought to cover the entire universe. Everything is moving in a field that you are in right now, that everything is in. And in this field, particles slow down and gain mass. Otherwise, they would move at the speed of light and everything would turn into energy, and there would be nothing at all. Peter Higgs predicted this field in the 1960s. but it was proven with the discovery of the Higgs boson in 2012 by the particle collider at CERN. Peter Higgs received the Nobel Prize in Physics in 2013 for this discovery. What we call the Higgs boson is a particle created by the waves generated in this all-pervasive Higgs field. To create these waves, you need to collide particles and create a wave. The Higgs boson, which was discovered in this way, is the particle that gives mass to all the particles we know, and therefore to us, together with the Higgs field, as I mentioned earlier. That is why it is also called the God particle. Physicists don't like this term very much, by the way, but isn't it catchy? If you ask why this Higgs boson is important, that according to some scientists, could be a portal that could explain the dark matter that holds matter together. We are not there yet, but work is ongoing. When we can explain dark matter, we will be able to explain how galaxies, galaxy clusters, and everything in the universe came to be. But dark matter has an even darker enemy. The other hero of the war I mentioned at the beginning. When astronomers study distant galaxies, the remnants of the Big Bang, they discover something. As expected after the Big Bang, the universe is slowly expanding until 8 billion years later. It was even thought that this slowdown would stop after a while and collapse in a phenomenon called the Big Crunch. But 8 billion years later, something is happening. Something very strange. The expansion of the universe suddenly accelerates. It's getting faster and faster. And as we know today, it's going to accelerate even more. Today, this expansion is thought to be about 240,000 kilometers per hour. It's only going to get faster, and our data suggests that it will go on forever. So what happened? What caused this extraordinary event? We don't know. That's why we call it dark energy. The extraordinary force that is thought to cover 68% of the universe, that we are sure exists, but that we don't yet understand. But let's talk about that in another video. Let's continue the series with dark energy, and then some very exciting topics await us. Before we finish, your support is very important for Art of Science to continue forever accelerating like the expansion of the universe. I look forward to your support by subscribing and liking the video. In the coming period, I will have some very nice surprises for my supporters who contribute through these channels. Thank you very, very much in advance. Be sure to follow us on my Instagram and YouTube Shorts channel. And as always, until we meet again, I'm glad to have you. Love.